Now let us look at vector algebra. Okay, try to understand the various concepts here. Okay, so here I'll be taking a few vectors now. Okay, let us take uh, a vector A. Okay, just I, J, and K. B 2I minus 7J minus 3K. C 1 by root 3 I plus 1 by root 3J minus 1 by root 3K. So I have three vectors here. Okay. Now let us find um, the magnitude of these vectors A, B, and C. The general formula for this, suppose if I consider OP as a vector, okay, magnitude of this vector, or it is represented by R, okay, so which is square root of x square plus y square plus z square, where the general form of this is xi plus yj and zk. Okay, so mod a will be square root of 1 square, and this would be root 3, followed by mod b will be square this, and this will be 2 square and 49, okay, and 9, and this will be root 62, and this will be uh, 1 by 3 and 1 by 3 and 1 by 3. So this will be 1. Okay. So here we understood the concept on how do we find the given vectors A, B, and C. Okay. We found the magnitude of this. Okay. Now let us look at one more example and try to understand another concept here. Okay, suppose I've been given a vector A, okay, which is I minus 2J plus 3K. Another vector which is B 2I plus J minus 3K. Okay, so in the previous problem we found the magnitude. Let us find the magnitude of this. So mod A, I already found this, which is root 16, root 14. Okay, and mod B, which is root 14. Okay, now if you notice this here, magnitudes of these two given vectors are same. Okay, but here these vectors are not equal. Okay, magnitude are same, but these vectors are not equal. Okay, okay, now let us try to understand another concept here. P as I, J, and K. Q as 2I plus 2J plus 2K. Okay, now here a new concept which we are going to find the direction cosines. Okay, so direction cosines uh, of P will be uh, 1 by the magnitude of this, that is square root of 1 plus 1 plus 1, which is 1 by root 3. Okay, and this will be a. Okay, and b will be 1 by square root of 1 square, 1 square and 1 square, which is 1 by root 3, and c, which is 1 by square root of 1 square, 1 square and 1 square, which is 1 by root 3. Okay, these are the direction cosines of uh, pi, uh, that is p, vector p. Let us find the direction cosines of q, okay, which is a is equal to 2 by square root of, this is 2 square plus 2 square plus 2 square, which results as 1 by root 3, and b will be 2 by, again, uh, this will be 2 square plus 2 square plus 2 square, this is again 1 by root 3, and c 2 by square root of 2 square plus 2 square plus 2 square, which is 1 by. Now, as you can see here, um, the direction cosines of P and R and Q are equal. Okay, that is 1 by root 3 and 1 by root 3 and 1 by root 3 for this. But if you look at these vectors, which are not equal. Okay, so in the previous case, the magnitude which you found are equal and the vectors are not equal. Here direction cosines are equal. Okay, and the vectors are not equal. Okay, p is not equal to q. Okay, so from these two examples, we have seen that two vectors having same magnitude, uh, they cannot be equal. Okay, and two vectors having same direction cannot be, vectors is not equal. So these are the concept which we understood now. Okay, okay, we'll solve few more problems. Now let us try to understand another concept here. I've been given a vector a, which is I plus j plus 2k. Okay, to find the unit vector, that is a cap, is a by mod a. Okay, so that would be I plus j plus 2k by, this is root 6, or it can be written as 1 by root 6 I plus 1 by root 6 j and 2 by root 6 k. So this is a unit vector in the direction of a vector which is a. Let us see, suppose if I have been given two vectors, which is a 2i minus j plus 2k, another vector b, which is minus I plus j minus k, right? Um, suppose I sum this, and let us find what happens if I sum this and find the um, unit vector of this. Okay, so again, this is a plus b, sum of this, which would be uh, I plus k. Okay, now for this magnitude would be mod a, which is root 2, and the unit vector will be for this, for the sum of this, would be a plus b by mod a plus b. Okay, so which is 1 by root 2 I plus 1 by root 2 k. Okay, now let us see one more problem. Now suppose if I have uh, a vector a, which is 5i minus j plus 2k, which have we will find the vector which is in this direction. Okay, of vector which is a, has a magnitude of 8 units. Okay, so that is 8a. Okay, so 8a. Okay, so a, uh, a is this. Okay, mod a will be root 30. Okay, and a cap will be, the unit vector is a by mod a, which is equal to 5i minus j plus 2k by root 30. Okay, now this vector has has a magnitude of 8 units. So this is 8a, which is equal to uh, 8 multiplied with 5i minus j plus 2k by root 30. Okay, so after simplifying it, we get 40 by root 30i minus 8 by root 30j plus 16 by root 30k. Yeah. Now let us understand the concept on collinear. Okay. Suppose I have been given two vectors, which is a 2i minus 3j plus 4k. Okay. I have one more vector, which is b. Okay, which is minus 4i plus 6j minus 8k. Okay. So if you look at the relation between a and b here, so b will be, if I take minus 2 outside, so I get 2i minus 3j plus 4k. Okay, which is equal to minus 2, uh, the vector a. So if you look at this, b is equal to lambda times a. So here lambda will be 2. So if you look at these two vectors are collinear. Now and let us look at another concept here. Given, have been given vector a, 3i minus 4j minus 4k, b 2i minus j plus k, C I minus 3j minus 5k. Okay, so the points A, B, C with these position vectors, okay, they respectively form the vertices of the right angle. So AB will be B minus A, okay, which is minus I plus 3j plus 5k, and BC will be C minus B. Okay, so this will result minus I plus 2j minus 6k, and CA is A minus C, which is 2I minus j plus k. And if you look at this, mod of AB whole square will be 35, mod of BC, okay, whole square is 41, okay, and mod of AB, sorry, this is CA is 6. Now AB whole square plus CA whole square is equal to 35 plus 6, which is 41. This is BC whole square. So ABC is a right angle triangle.